Let's review some of the key vocabulary for Unit 4. First, the triangle sum theorem. Triangle sum theorem. The sum, remember sum means adding, the sum of the interior angles of a triangle is 180 degrees. Sum means we have to add them together. So give yourself a little picture of a triangle and we'll label the angles 1, 2, and 3 and we'll say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Only the angles. The exterior angle theorem. So first of all, let's draw a picture of a triangle and extend one of the sides such that we see an exterior angle like this angle right here. Let's label that angle. We've labeled that angle 4 because the 3 interior angles we'll label, just like we did in the picture above, angles 1, 2, and 3. So the exterior angle theorem says we add the measures of, in this picture, angles 1 and 2, and it equals the measure of that exterior angle. How do we know which ones we're supposed to add together? These are the remote interior angles, the interior angles that are farthest away from the exterior angles. The sum of the remote, the ones farthest away, the remote interior angles equals the exterior angle. What else do we have? Different types of triangles, it's important to know: an acute, obtuse, right, equiangular triangle. All of these refer to the types of angles. An acute triangle is a triangle that has 3 acute angles. 3 acute angles. All of the angles are acute. An obtuse triangle is a triangle with 1 obtuse angle. Why only 1? Well, if we have an angle that's more than 90 degrees, let's show a picture of it. Here's an obtuse angle to start with that's more than 90 degrees. If I connect the other 2 sides, notice the angles that are left have to be acute. Think about how many degrees all 3 angles are supposed to add up to. Can more than one angle be bigger than 90 degrees? What is a right triangle? That's a triangle with 1 right angle, which is a 90-degree angle. If you're drawing a picture of that, you're going to first start with a 90-degree angle and then connect to make the 3rd side. Equiangular. Equi sounds like equal, and that's exactly what it is. All 3 angles are equal. All 3 angles are congruent, and if they're all congruent and they have to add up to 180 degrees, remember that those 3 angles have to be 60 degrees. So this is a triangle with 3 congruent angles. All of the angles are the same measure. Remember that if a triangle is equiangular, it's also equilateral. Equilateral means 3 congruent sides. So we can also mark the sides congruent in this picture. Speaking of sides, let's talk about this equilateral triangle. Equi, again, equal. So if you're drawing a picture, it's the exact same picture we just drew where all 3 sides are equal. We can do a better job of that. Let's try to make all 3 sides look the same length, and whether or not we're good at drawing that, we can always mark it with congruent slashes. So equilateral triangle with 3 congruent sides. And just like we did in the other picture, remember that equilateral means equiangular. One doesn't come without the other. So equiangular, so all the angles congruent. Let's back up for a minute to scalene triangle. This is a triangle with no congruent sides. If you don't remember these yet, you're going to have to memorize them. So I'm going to try to draw a triangle that looks like it has no congruent sides, but if I put different congruent slashes through the three sides, that can kind of indicate that as well. Isosceles is a triangle with at least two congruent sides. At least two congruent sides. So we'll draw a picture where these sides look congruent. Remember, the base angles theorem tells us that if two sides are congruent, the base angles are also congruent. So the base angles theorem tells us the base angles of an isosceles triangle, the picture that we just drew above, the isosceles triangle, are congruent, which is just what we showed in this picture above. Two sides congruent, two angles congruent. Moving along. Congruent figures. Congruent figures have the same size and shape. Same size and shape. The corresponding parts are the parts in the same positions. So if the figures are congruent, there is a correspondence between the parts such that all of the corresponding sides and angles are congruent. So congruent figures have the same size and shape, which makes all the corresponding sides and angles congruent. A congruent statement tells us that the figures are congruent. Tells us that the figures are congruent, and it tells us which parts correspond. For example, I might need to write that triangle ABC is congruent to triangle PVH. And from this congruent statement, I can see which parts, such as angle A and angle P, correspond or are congruent. Then we have the postulates or theorems that help us tell that triangles are congruent. The side-side-side postulate is where we have two triangles that have three pairs of sides congruent. So the best thing to make a note of for the side-side-side postulate is showing yourself a picture of what it would look like if we were to use the side-side-side postulate. Two triangles where the sides of one triangle are congruent to the sides of another triangle. The side angle side postulate, the two of the sides, two pairs of sides are congruent, and then the angle in between, that's called the included angle. The angle between the two sides is also congruent. Then we have the hypotenuse leg, is a theorem that is only for right triangles. Why? Because only a right triangle has a hypotenuse. So if you draw two right triangles, show that's a right triangle there, and show that's a right triangle there. Then the hypotenuse leg theorem says the hypotenuse is congruent to the hypotenuse, and one of the legs is congruent to one of the legs. Now when you label these sides, what you'll tend to notice is that you have SSA, or it looks like you're spelling the bad word, which we know is not one of the theorems. But if it's SSA and a right triangle, then we know that it's hypotenuse leg. Then we have the angle side angle postulate. Let's show what that looks like. Draw your two triangles. We have two pairs of congruent angles. And then the side that's congruent is the one between the two angles. So from angle to angle, that's side connecting. Angle to angle, that's side connecting. That's the angle side angle postulate. The angle angle side postulate can often be confused with the angle side angle postulate. So let's again show the two pairs of congruent angles, but this time we want the pair of congruent sides to not be between the two angles. So this is the side that's connecting the two angles, so we need to pick the side not between them. So again, this is the side connecting the two angles, so we're going to pick the side not between them to be the pair of congruent sides. Finally, when we say we're going to make a proof, that really just means we're going to talk through or write everything down. We're going to write what we know, and when we write what we know, those are the statements. Which angles are congruent to which angles, which sides are congruent to which sides. And we're going to write why we know it. And why we know it, that's the reasons. Using a proof, we often need these properties. The reflexive property of congruence is when we know the shared side of two triangles is congruent to itself. For example, in a triangle, I may in a picture, I may have, here's one triangle, and here's another triangle that's touching it, and this side is congruent in both triangles. Let's name the endpoints of this side A and B, and I would say side AB is congruent to side AB by the reflexive property. Symmetric property isn't one that we use very often, but if you see it, it looks something like this. First, we're going to say AB is congruent to PV, and following, we would need to flip around the statement. So this one's not as useful as other ones, but you may see it from time to time. Transitive property, another one we don't see too often, but it basically looks like this. Transferring one statement onto another. If AB is congruent to PV and PV is congruent to JL, then, well, how do we transfer the one statement onto the other? We take the beginning and say it's congruent to what's at the very end, because both of these are congruent to PV. Very much like which law that we talked about in logic. Yeah, like the law of syllogism, but with symbols instead of words. All right, see you in class.